Welcome back, my Math 2 people. If you're trying to do these next exercises with the circles and the inscribed angles and the inscribed square, this will help you out a little bit. Let's talk about first inscribing a square. You see now I've drawn this circle. I use my compass. To draw the circle with the center at C. And now I'll take I'm going to show you two different ways to do this. Okay? If you have a protractor, then you've got your life easy. Okay? You can take your protractor and draw in a diameter. Okay? I'm just going to label this so you have points of reference. A and B. Being really creative here. A, B, and C. C for center, A and B for other points. The two ends of the diameter. Okay, remember we have a radius here from C to A, and that's how you generate the circle with that radius, sweeping around. We want to now construct a square inside of this circle, inscribe a square. Now we could do the whole construction thing. We take our compass, put the point down, it's hard to see through the camera. Make sure our compass is more than halfway open. Más que la mitad. And then you'd arc above, arc below, switch sides, get to your B, arc to cross, arc to cross. Then you connect it. Now, if you have a protractor, you can save yourself a little effort just by saying, oh, well, I got a protractor. Shoot, I want to make a perpendicular. Do this right side up for you. Because we know a line, if you have a perpendicular, line these lines up, line them up with the sides, line it up. And you can see here's our 90 degrees, that's our perpendicular. I can just put a point above that, and then I can just connect that point. And if I'm accurate, this point and these two things will still be the same. And you can see, except for the fact that I ran off the edge of my protractor, okay, that we have a perpendicular bisector for our diameter, hence another diameter. Then, taking our color, I'm going to still use this one because it's nice and small. We now have 4 points, which make the 4 corners of the square. Sorry, my focus keeps going off because my hand keeps getting in the way. 1, 2, 3, 4. 1, 2, 3, 4. And I'm on the edge of this thing here. We can draw in our square. Now what we're doing here is preparing yourselves for how you're going to make a mandala. I'll give you another video with the explanation of that, with the criterion for that project, which is coming later this week, maybe even later today. And there you go. There you have a square inside a circle. Now you can continue this idea. We can now put a circle inside of that square. Because if we're going to make a mandala is essentially, these are the two basic elements, a circle and a square. Now the square can be inscribed in the circle, and the square can also be circumscribed around your circle. The square can be. Or we can make another circle inside of our circle. To do that accurately, without using measurements, we would take our compass and we'll open it more than halfway, and we'll do our bisecting. Bink. I hate how this focus keeps changing. A bonk. Switch sides. A kadink. And a kadonk. And we see these 2 points, we'll connect them. We don't really want to connect them, we just want to line them up So we can then see where that midpoint is of our side, which is right here. And that tells us how big, what the radius will be for our circle to inscribe within this square. So take your compass, put it on the C, the center, and close it down to where you are on that point. And if you're completely accurate, which I may not be because I'm not always so accurate, manipulating this to the camera is not the easiest of things. And you can see my circle is going round and around and around, and it stays inside, and it stays inside, and it touches tangentially. Okay. When a line touches a circle at one point, we call that tangentially arriving. So this line A, we call this X and Z. So this segment AX is tangent to this little circle C because it touches the circle here at only one point. And you notice I use this distance to make my circle. So that's my radius. And my radius is now, you can see it's a perpendicular line because I drew my perpendicular bisector. It's a perpendicular line to this tangent line. And I'll even write those two words down so you can have them in your vocabulary. A tangent line, a line tangent to a circle is perpendicular to the radius of the circle. So line tangent, we call that the tangent line if it's perpendicular to the radius and it touches the circle once and only once, one place. Okay, so that's what you'll be doing with number 9 on that page in the textbook that I assigned to you for this segment, constructing a square inscribed in a circle. We'll get down to this part. Well, I may as well do it right now. Do it all at once. Make one long video. Okay. The other portion of that thing was using the idea that we talked about in the other video, where this angle here is a 90-degree angle, this angle is a 90-degree angle. You can see that it cuts off exactly half the circle. So that makes this arc length, A to B, an arc length of 180 degrees. And there's this thing about inscribed angles in that their measure is exactly half the arc that they subtend, that they cut off. So that means this has to be a 90-degree angle because half of 180 is 90 degrees. So we use that same concept when we have irregular quadrilaterals inscribed in a circle. There's 4 points on the circle, and we've connected them with chords. Okay, remember, chords are those segments that connect to one point on a circle to another directly, not on the circle. Okay, that would be an arc. SR is an arc. SR is a chord. It depends on how you label it and look at it. Now we just figured out that angles that are opposite of each other have to be supplementary. They have to add up to 180 degrees. So that means this angle here, this little angle S, and this big angle Q, they have to add to 180 degrees. We also know that a quadrilateral is, the sum of all its angles is the sum of 2 triangles. So the sum of all the angles equal 360 degrees. Okay. And we know these two together add up to 180. So we know we can take our four angles, 5x plus 20 plus 10x plus 7x minus 8 plus, oh, we don't know what this one is. Well, we know these two together add to 180, so this one has to be whatever this one is subtracted from 180 to get that. So we got our last expression, 180 minus 10x. And all of that is going to equal 360 degrees. And then we use our algebraic rules. Remember algebra, don't ever forget the algebra. That's what this is all about. It's remembering our basic algebra. 5 plus 10 is 15, plus 7 is 22, minus 10 is 12. So we only have 12 x's here. And then we got this 20 minus the 8 plus 180. 20 minus 8 is 12, plus 180 is 192. Equals 360. And it's an algebraic equation. How do you solve an algebraic equation? Yes, you must subtract this 192 from both sides. And for you lazy people, 360 minus 192 and you see that's 168 degrees. Oh, 168, yeah, degrees. So 12x is 168. And then remember the rules of algebra. That's 12, so we have to take 1/12 of it and 1/12 of that, and everyone 168 14 times. And then we go back and we figure out how much is the measure for each angle. Well, obviously 10x is 140. And so that makes S has to be 40. And 5 times 14 is 70 plus 20, so this is a right angle. 90. And this one is 7 times 14. They're opposite angles. It should be a 90-degree angle too, right? Because these make 180, so these are opposite angles, so this got to also be a right angle. That means that we now solved our situation. Opposite angles in an inscribed quadrilateral are supplementary, meaning they add to. What's 140 plus 40? What's 90 plus 90? That's right, they add to good old 180 degrees. Okay, opposite angles of an inscribed quadrilateral. And with that information, you should be able to do that assignment. No problem whatsoever. And I really, really, really want to emphasize that number 9 and number 14, where you have to do the circle, the square inside of the circle. All right, more coming. Take care.